Hi, this is Mr. Manley, and today we're going to take a look at complex numbers. So, complex numbers are all of the numbers that we already know. So, they are all the real numbers. So, any number that you've already worked with, which would be fractions, negative numbers, square roots, those are all real numbers. And then what the complex numbers do is that opens up something called the imaginary numbers, I. And then all of these taken together, all of the real numbers and then the imaginary number, which there's really only one imaginary number that we combine with real numbers. And that creates the set of complex numbers. So this imaginary number, just the first thing to say about it is it's not an imagination number. It is an actual number, but it doesn't have the sort of value that we normally associate with numbers. And that's something that you need to discuss with your teacher about what that means exactly. So I do want to briefly look at where it comes from. If I take the idea here is if we look up on the left, and if I take this rad -4, what is that asking for? That's saying what number multiplied by itself twice is equal to -4. So it's like I want to know what times what is equal to -4. And no matter what I do, I'm not going to be able to answer that, right? Now, if it had been a cube root, say I had a cube root like the cube root of -8, that's saying what number multiplied by itself 3 times is equal to -8. And I'm going to be able to answer that that's -2. So I'm going to be able to deal with a negative radical with this cube root here, with that cube, because I'm going to multiply a negative times a negative times a negative and get a negative. So with odd roots, so if it were a 3 or a 5 or some other odd number, I can do negative numbers. But we've never been able to do that with an even root. So the square root is saying 2 numbers. What number times what number is equal to a negative number? And we have not been answering that. Well, what we're going to do is we're going to go back to the property of logarithms, or not the property of radicals that I keep coming back to with my students, and that is that the square root of xy is equal to the square root of x times the square root of y. So we can always split up these radical expressions, right? So I'm going to take the square root of -4, and I'm going to split that up into square root of -1 times the square root of 4. Well, so here we can make some progress. So the square root of 4 is 2, but I'm still sitting here with this square root of 1 and saying there's no number multiplied by itself that is equal to -1. Well, we're going to say that there is a number now, and we're going to call the number that you can multiply by itself to get -1, we're going to call it I. And really, all we're doing with I is any place where we would be looking at a rad -1, anytime we get down to that, we're just going to replace it with I and say the number that multiplied by itself twice is equal to -1 is I. It is some non-real number. It's not a number that we can put on a number line, but it is a number. We call it an imaginary number, but there's nothing imaginary about it. It is an actual number. So this 2 rad -1, I'm going to rewrite as 2I. Now, if you don't understand all that, or if that seems a little bit confusing, you're still going to be able to make some progress in your study of complex numbers, because the actual work that we do with complex numbers is really, really pretty simple. The only thing you need to know is that whenever you get to rad -1, you're going to replace it with I. And then there's one other thing you need to know. You need to know that I times I is I squared, right? And then you also need to know that since I is rad negative 1, I times I is rad negative 1 times rad negative 1. And what's the square root of anything times itself? Like if I do the square root of a times a, what's that equal to? That's equal to a. So the square root of negative 1 times the square root of negative 1 is equal to negative 1. And that means that I squared, whenever I see I squared, that's equal to negative 1, looking at the middle of the screen there, down toward the bottom. So I times I is I squared, and I squared is equal to negative 1. So whenever we see, so these are the two things that we're gonna do. Whenever we see rad negative 1, we're going to replace it with I. And whenever we see I squared, we're going to know that that is equal to negative 1. So these are really the only two ways that you have to deal with something new if you understand that. And if you don't really understand anything else about it, you can still make progress. All right, so what we're going to do now is we're going to just do some operations with imaginary numbers. And they just behave like variables. So it's really pretty simple. If I take this first one here, I'm going to have 12 minus 2i, and then I'll distribute this negative here. I'm going to distribute that here and here. So that'll be minus 8 plus 3i, and then I'm just going to combine the like terms. So I got 12 minus 8, which is 4, and then we've got minus 2i plus 3i. Just behaves like a variable. So minus 2i plus 3i is going to be plus 1i. Okay? So that is just simple addition and subtraction of complex numbers. The second one, we're going to do some multiplication. So I've got 3i here times 2 minus 3i. Distribute, and I get 6i, and then minus 9i squared. So make sure you see that. So 3i times 2, that's 6i, and then 3i times 3i, that's and there was a minus there, so that's minus 9i squared. Now remember what we said. Wherever there's an I squared, we're going to replace that with negative 1. I squared always gets replaced with negative 1. So let's go back to where we were here. So this I squared right here, that's going to get replaced with negative 1. So again, I mean, if you this talk about imaginary numbers and where they come from and what they are is confusing to you, doesn't matter. You can still do these operations. Just I is standing in for rad negative 1, and when I have I squared, as I did here, I'm going to substitute negative 1 for that. And then that'll simplify. One thing about complex numbers, which are numbers that can have an imaginary part, we typically write them, you notice how I changed the order here. So we typically write the real part, and then the real coefficient, and then I. That's called the standard form of a complex number. And it's, so it's saying A, the real part, plus B, the real part, times I, is the way that we typically write it. And we'll see an example where that's important in a moment here. All right, so next, this one is just a FOIL. So we do need to get both binomials here, and this will be 9 plus 6i plus 6i plus 4i squared, and there's the I squared again. That's going to get a negative 1. So if I can kind of skip ahead a little bit here, that's going to be 9, and then this last term here is 4 times negative 1. So it's going to be 9 minus 4, which is 5, and then these other two here, this 6i and this 6i, we're just going to be able to add those and get 12i. Okay, simple enough. We'll just look at one more thing here. So first of all, if you recall some work with radicals before, so this first one up here, right there, that doesn't have anything imaginary, but I just want to remind you about rationalizing the denominator by using the conjugate. So I would multiply this by 2 plus rad 3 over 2 plus rad 3. So hopefully you remember that, and that's how we rationalize the denominator when there is a radical in the denominator. Well, since I is rad negative 1, does it make sense that there's a radical in the denominator here? This imaginary number is kind of like having a radical in the denominator. I'm going to rationalize it through the same procedure as I do for any radical. So I'm going to go 3 plus 4i over 3 plus 4i. 3 plus 4i. And then we just multiply across 15i plus 20i squared, and 9 minus 16i squared. Okay, and then simplify that a little more. So I was able to get that simplified down to this, and if you need to pause that and go back and see how I did that, you should do that. Now remember that I talked about this standard form here, right? A plus bi. Well, I'm going to write this in that standard form. See if you can follow how I do it. It's going to be negative 4 over 5 plus 3 over 5i. So see how I rearrange that and put it in the standard form order. So that's an introduction to imaginary numbers and the operations with imaginary numbers. You should be able to do a lot of them, I think. I'm sure you'll still have questions, and when you see your teacher in class, you can clarify any questions that you have. Good luck.